Today we're going to talk about isosceles and equilateral triangles. So we're going to be able to answer these two questions at the end of the lesson. What's true about the base angles, and what's true about the triangle sides in both isosceles and equilateral triangles. The first thing that we need to talk about are the different parts of isosceles triangles. The first are the legs, which are the two congruent sides in an isosceles triangle. The second piece that we're going to discuss is called the base. So the base is the side that the two equal sides connect. Okay? And then the next is the base angles. So here in this case, if this side and this side are congruent, our base angles would be here and here. Alright, and then the last thing we discussed in an earlier lesson is the vertex angle. In this case, this here would be the vertex angle. Alright, so we have these different pieces. So when we refer to the legs, that's the two congruent sides. When we refer to the base, that's the third side that's not congruent. When we refer to the base angles, we're talking about the two congruent angles here. And then when we talk about the vertex angle, we mean the angle that is not the base angle. The next thing we're going to talk about is two theorems. First of all, theorem 4.7 is the base angles theorem, which tells us that if two sides of a triangle are congruent, then the angles opposite those congruent sides are also congruent. And a corollary to that deals with equilateral triangles. So if it's an equilateral triangle, then it's also equiangular. And all that's telling you is that if you know a triangle's sides are the same, so say this is 5, 5, and 5, then we know its angles have to be the same as well. Alright, the converse of that tells you almost the same information, but then you're starting with the sides of that triangle. Or you're starting with the angles. So if two angles are congruent, then the sides opposite those angles are also congruent. And then it also works for equiangular triangles, then we know they're also equilateral. Okay, so we're going to use those in a few examples today, and we'll see how they come into play in a little bit. First of all, let's just take a look at naming some things in triangles. If we look at this triangle RTI, we notice that there's two congruent sides. So side RT is congruent to side TI, which tells us it has to be an isosceles triangle. And the base angles are the two that are opposite the congruent sides. So that would be this angle R and angle I. The vertex angle then is the leftover angle, which would be T. And then we could figure out the measure of that angle T. Here's how we do it. We know R and I are congruent, so this has to be 58 degrees also. Well, if that is 58 degrees, we know that if we call this angle TX plus angle R plus angle I needs to add up to 108 degrees. So if you combine your like terms there, that would end up being 116. So x plus 116 equals 180. And if you go ahead and solve that for x, you're going to end up with 64 degrees. So angle x, or angle T in this case is 64. Let's look at another example. This triangle ABC, we can see that all three angles are congruent. So I'm going to use theorem 4.8 and say if it's equiangular, it is equilateral. So I've got an equilateral triangle here. And if it's equilateral, what do we know about the three sides? They're all the same. So since BC is 11, that tells us AB is 11, and CA is also 11. Now, to figure out the degrees in an equilateral triangle, what we know is that they all add up to 180, and they're all the same. So if we would say 3x equals 180 degrees, if you divide that into 3, you end up with 60 degrees. So the measure of angle A is 60, the measure of angle B is 60, and the measure of angle C is 60. And they all add up to 180, and they're all the same. We're going to throw some algebra in the next few examples here. Example 1, we're going to find the value of x. Well, we can see here that this is an equilateral triangle, so it's also equiangular. So these three angles are congruent. And we just saw in this last example that if it's equilateral, the angles are all 60. That means we can take 5x, set it equal to 60, and solve. Dividing by 5 will get us 12 for x. Then in example 2, we have an isosceles triangle. Notice EF is congruent to ED. So if that's true, we know D and F are congruent. I'm going to call those Y, because X is already used. And then I'm going to figure out how many degrees Y is. So Y plus 40 needs to add up to 180. Or 2y plus 40 equals 180. If we go ahead and solve this, we'll end up with 2y equals 140. So y is going to end up being 70 degrees. Now I can set up an equation to find x. If y is 70, well, then we can say 11x minus 18 has to equal 70 degrees. Go ahead and solve, and you should end up with x equals 8. We're going to challenge ourselves a little bit more in the next example. Notice that we have x in all three sides. So this is going to be an equation with variables on both sides. This is equiangular. All three angles are the same. So we know it's also equilateral. Now it doesn't matter which two of these equations you use to set up. I am going to use the 12x minus 13 and the 2x plus 17. I can just set those two equal to each other and not even use the 7x plus 2. Okay, and then we're going to solve this, so let's get the x's all together by subtracting 2x from both sides. We'll get 10x minus 13 equals 17. If we add 13 to both sides, then we're going to get 10x equals 30, so x is going to equal 3. All right. The last two examples in your notes are a little bit more of a challenge, so we are going to look at those together in class.